Okay, we're now ready to do part 5, calculating the speed and distance using Newton's second law. So we're going to continue to use the motion simulator, and we're going to select a 50 kilogram box. So we're going to get rid of the refrigerator, and then we need to put on the 50 kilogram box. We're going to need all of this stuff activated, including a stopwatch. Now, you don't have to use this stopwatch, so if you want to use your cell phone as a stopwatch, you can do that, but one of them is provided here. And so continuing with the motion simulation, use the 50 kilogram box, click on the values, the masses, the speed, and the stopwatch. And then this next part may require 2 people to do it, because you're going to have to be using the stopwatch and you're going to have to be moving the slider to provide the force at the same time. So it's easier if you have a cell phone, and then what you can be doing is with one hand you can be manipulating the force, and then with your other hand you can be turning on and off the stopwatch. And if you got another person to help you, that's even better. So we're going to set the slider to 100 newtons. While holding the slider at 100 newtons, time how long it takes for the box to move 5 increments. So this, you can think of this thing as being on railroad ties. So these are the increments. So 1 increment, 2 increments, 3 increments, and so forth. You may have to do this 2 or 3 times in order to get some good results on this. Because, okay, so I'm going to try to do it here. I need to click my stopwatch, turn it on, and then very quickly turn this thing on. Okay, and then, okay, and it needs to move 5 increments, and I've already lost count how many increments it's moved. So you can see why this one is kind of difficult, and you're going to probably need some help with it. So you're going to time how long does it take for this thing to move 5 increments. And then once it's moved 5 increments, you can, so let me reset it here. Actually, what you can do is you can do the stopwatch part by itself, and then you can do the speed part by itself. So don't even look at the speed, the speedometer, but you do need to have your stopwatch. You start it, give it your force, 1, 2, 3, 4, 5. Okay, now I got my speed for 5 increments up here. Now I hope I did that right. So you want to do that to make sure that you got the right numbers on that. Now you're going to be putting all of this data down here into this thing here. So it says, what was the measured force that you applied? Okay, so we're going to go back up to here, and it said that the set the slider to 100 newtons. So 100 goes right here. Okay, what was the mass of the crate? So put that number right here. What was the number of increments that it moved? Okay, so it says here you're going to move 5 increments. So go ahead and put that number here. Measured time elapsed using the stopwatch. So put that number there. Measured final speed of the box using the speedometer. So put that number right here. Okay, now using Newton's second law of motion, calculate the acceleration of the box. So here is Newton's second law up here. You know what the force is. You know what the mass is. So calculate the acceleration. And you're going to put that into this box here. So calculated acceleration of the box using Newton's second law. So put that in here. Okay, calculated final speed of the box using the how fast equation. So the how fast equation is this one here, which is going to say that the final speed of the box is going to be equal to the initial speed of the box plus the acceleration times time. But what do we know about the initial speed of the box? So before you applied the force to the box, how fast was it going? Okay, so that means that this part isn't even there. You know the acceleration and you know the time. So calculate the final speed of the box. And then you can compare that to the measured final speed of the box with the speedometer. So this one and this one down here ought to be the same. Okay, then calculate the distance the box moved. So this time we're going to use the how far equation, so that the distance it's going to move is its initial speed times time plus 1/2 the acceleration times time squared. But once again, can we simplify that formula? Yes, we can. I'll let you do it, but one of those pieces is not going to be there. And you're going to know the acceleration from up here, and you're going to know the time from the stopwatch, and you're going to calculate the distance that the box moved. And you're going to put that into this box here. Okay, then, so let's say that our answer turned out to be 18. It's not going to be, but let's say that it was 18 meters. And the very last thing that we need to do is to calculate the distance per increment. So how many increments were there? 5. So we're going to take 18 divided by 5 and whatever that number is, and then put it into this box here. Now I've done this, but, and I've gotten a 6. So the answer should be about 6 meters per increment. And then record that number here. Okay, now I just also want to point this out. So let's go back to the simulation. Now you should have a good idea for what a railroad track looks like. And these things here are supposed to be the railroad track ties. The wooden thing that goes across the rail or under the rail. And normally, what's the distance between those ties? Well, it's normally about this big, okay? But what have we just figured out? 6 meters. So 6 meters is how many feet? About 18 feet. So the distance between these railroad ties is 6 meters or about 18 feet. So what does that tell you about this guy over here? This is a giant. So this guy must be what? Let's see, if this is 6 meters, it looks like he's 12 meters, so he's about 36 feet tall, 3 stories tall. So it's not a very accurate simulation, but they had to make these things so big in order for you to be able to see them. So it's okay, but I just thought that was kind of humorous. All right, so now we are ready to do our post-lab questions here. So what was the purpose of the lab? So go ahead and write that down here. What is mass? So find out on the internet exactly what is mass, and put that definition here. Okay, what is a force? So write that down here. Okay, what does a negative horizontal force mean? So if you got a negative force, -8 newtons, what is it telling you? What's the negative sign trying to tell you? Question 5, so we're going to add the forces together on this box. I did not put the negative signs on there. So some of these numbers ought to have a negative sign on them, and others are going to have positive signs. So you add and find the total force acting on this 5 kilogram box. Okay, question number 6. What is Newton's second law of motion? So go ahead and put that there. Okay, now question 7. A 20 Newton force is acting on a 5 kilogram object. What is its acceleration? So solve the problem, put your answer here. Number 8, a force on a mass causes it to accelerate at 5 meters per second squared. Now we're going to triple the mass but keep the same force. What would the new acceleration be? So you're going to be using Newton's second law in order to answer this question. Question number 9. A object of mass 2 kilograms is acted upon or has an acceleration of 3 meters per second squared. How much force is acting on it? So again, use Newton's second law to solve this one. And then an object is traveling at a constant speed. What is the net force acting on the object? So this is kind of your bonus question down here. It's not for bonus points, but this is your kind of a tricky one. If something has a constant speed, then that should be telling you something about its, begins with the letter A, and then that should tell you something about what's the force acting on it if it's producing that thing that begins with the letter A. All right, so see if you can answer those questions. And so that concludes this lab about what forces are and then what forces do. So until next time, I'll see you.